So the first session here is Newton's laws, work, energy, and power. Why did I group them together? We're basically talking about the same thing. All right. We are going to draw free body diagrams. We're talking about forces. We're going to talk about speed. We're going to talk about acceleration, displacement. Hence, I group them together. All right. So normal force. We should know what normal force is. It's a force exerted by the surface on an object, and it is perpendicular to the surface. So what you need to do is, as I'm talking, going through the definitions, for those of you that are here, you need to make a list. Make sure you are able to define all of this. Definitely, we will not go beyond this as we expect questions to be asked. All right, so it is a force that is perpendicular to the surface that you must know, and it's from the surface. It means if there's no surface, there is no normal. Number two, frictional force. It is a force exerted by the surface on the object, which is parallel to the surface, very key, and it acts in the opposite direction of motion. At this stage, if you still think friction is acting against applied force, we have a problem. Friction is not a force opposite applied. It is a force opposite the direction of motion. Please, let's take note of that. It is a force opposite the direction of motion. What is velocity? Velocity is the rate of change of displacement. Velocity is the rate of change of displacement. It is different from speed. So please take note. Speed is the rate of change of distance. It is a scalar quantity, while velocity is a vector quantity. It has to do with displacement. What is acceleration? Acceleration is the rate of change of velocity. Now, look, these are definitions that you should know by now. Acceleration is the rate of change of velocity. And some of these you can get from your formula page. Very easy to get from your formula page. I'll show you a few things as we go. Let me show you something about acceleration. I know that if I go back to equations of motion, I know that Vf equals to what? Vi plus A delta t. All right. If I bring my Vi there, what would I have? Vf minus Vi equals to A delta t. Divide both sides by delta t. A, therefore, is what? Vf minus Vi over delta t. At this stage, you should also know that every time delta t is a denominator, we use the word rate. So from here, I see that, oh, Vf minus Vi, what is that? That is change in what? Velocity over change in what? Time. So what is acceleration, therefore? It is the rate of change in what? Velocity. So some of these things, there is no need to cram them. You can just use your formula page. Newton's first, second, and third law, that should be your second name by now. Newton's first law, an object will remain at rest, all right, or continue in uniform what? Motion until an external force acts on it. Newton's second law, when a net force acts on an object, what will happen? The object will accelerate in the direction of the net force with an acceleration that is what? Directly proportional to the net force and inversely proportional to the mass. Newton's third law, if object A exerts a force on object B will simultaneously exert a force on object A, which is what? Equal in magnitude and opposite in direction. Newton's law of universal gravitation. All particles on the earth exert a force of attraction on each other, right? And the magnitude of the force is directly proportional to the mass of the object, to product of the mass of the object, and inversely proportional to the square of the distance between their centers. take notes. Work energy theorem. The net work done on an object is equal to its change in kinetic energy. Conservative force. A force for whose the work done is independent or does not depend on the path taken. Non-conservative force. It's a force for which the work done depends on the path taken. Law of conservation of mechanical energy. In an isolated system, the total mechanical energy is, look, you have already secured certain marks in question 2 and question 5. All right? So all of these should be something you eat, something you, when they say what's your name, you give them definitions. Once we get all of these definitions in place, you are on fire, you are good to go. The next thing is to get your free body diagram. And once you get your free body diagram, calculation is done. Is that okay? So some calculations I'm just going to breeze through, some I'm going to allow you to do. Is that okay? You can get this, you still have a day or two to work over physics, right? So you need to, I have about 80, how many slides here? 80 something slides that you need to walk through. It's not that there's question on all of them. Some are just diagrams. So don't get scared. Okay. So if, for example, and I've tried to put different types of questions for you. A woman is, look, guys, I'm going to do something for you, and I hope you would learn this skill tonight and do that in your exam. A woman is pulling. Please, it's not Shakespeare. It's not a newspaper. Read every word with intent of understanding. The examiner is trying to say something with every word spoken. A woman is pulling. What does that tell you? What does that tell you? There's what? Lies. There's applied force. A woman is pulling. When you see the word pull, the word push simply tells you that what? There is applied what? Force. That's the first thing you need to do before you, some of you start from 2.1. You are killing yourself and wasting time. All right. We start from reading the question first. All right? Okay. All right. A woman is what? Pulling a suitcase of mass of what? Now, I can quickly tell you that I will pick a few things from that place. Those of you that have taught know what I'm talking about. All right? I know that the word pulling means applied force, right? The word mass talks about what? The weight. Now, when we talk about constant speed, that should quickly tell you something. What is that telling you? Acceleration is equal to what? Please take note of all those little things. This one talks about what? Force applied. This one talks about the weight, Fg. All right? What is this one telling you? Acceleration is equal to what? 0. All of those things are important. Up a ramp as shown in the sketch below. The ramp is inclined at an angle of what? 90 degrees. That's a very important, 30 degrees. That's a very, very important information there that the examiner is giving you. At 30 degrees to the horizontal. She pulls on a strap with a force of what? 51. Already we know our applied force is 51. The angle that the wrap makes with the suitcase is what? Theta. The kinetic friction on the suitcase is 1 Newton. Everybody, whether you are here, whether you are at home, please draw the free body diagram on the 8 kg. Quickly. Draw a free body diagram on the 8 kg. Quickly. This is where we start from. If you get this wrong, now we have a problem. Draw the free body diagram on the 8 kg. I have already outlined the important things. Number 1, pull. Number 2, mass. Number 3, okay, let me help you before you draw. Hold on. Number 1, pull, applied. Number 2, mass, there's weight. All right? It says on a ramp. It means there is a surface. And immediately you see that there is a surface, we know we are talking about what? Normal what? Force. All right? And then we go on to talk about kinetic what? Friction. How many forces are we talking about that I see? I see 4 forces. You're done. Come on. We should be done now, quickly. Guys, we're not going to waste time tonight. If you are here to make noise and talk, you would be far, far, far lost behind. You have a few more seconds to be done with that free body diagram. All right, you should be done and have it labeled. What's your free body diagram going to look like? The surface is inclined to the left. So it means my normal force should also be inclined towards the left. The applied force is not parallel to the surface. Take note. Some of you are going to get it wrong there. The applied force is not parallel. All right? The applied force is that way. It's not parallel to the surface. Okay, my calibration is not okay. My applied force is not parallel to the surface. Some of you have already lost 1 mark. All right, because you have cramped things in your head. Please. The questions will not be the same. What is that? Gravity. How is the object moving? Upwards. So friction should be acting where? Down the plane. Opposite. Please don't cram diagrams. Don't cram things in your head. The question will come with its own specific nature. Are we okay, guys? Please don't cram saying no, we did it like this in class. You'd be wrong. Can you see that angle there? So it's not, I know you are used to drawing things like this. Please forget about what you are used to. Examiner is coming with a different question, so please take note of what the examiner is asking you to do. So the force applied in this case is not what? Parallel to the surface. It's at an angle of what? Theta there. And then we label, right? What is this? That is the weight, or what you know, a force of what? Gravity. What is this? Force applied, all right. What else? Normal force. And what is this? Friction. But in physics, we always resolve inclined forces. Yes, talk to me. All right. If you add FG parallel, it's very dangerous. Listen, if you add FG parallel, remove the weight. If you are going to add FG parallel and FG perpendicular, remove the weight. Once you start adding extra forces, it's -1. My advice would be don't add any additional thing. Draw what it is first. Then you create a new diagram, which you see what I'm going to do. It's called a working diagram. If you check how many forces we identified while reading, how many forces do we identify? There were 4. I'll give you the keywords. Pull, applied. Mass, weight. Ramp, normal. kinetic friction, 4 forces. Once you draw this one, then you can start play, because once you make a mistake here, already you started losing the one that you need. So draw the original thing first. After drawing the original thing, then you can start playing around with other. You'll see I'm going to draw the inclined ones as well now. And that's my working diagram. All right. So already I have that. And let's go to the questions. Look at the first question. Define normal force. We did. Done. Number 2, draw a free body diagram. Done. Do you understand what I'm saying, guys? Do you see that without even looking at the question, or just by reading, we have already gotten our first what? 6 marks. Calculate the angle, see that the straps makes with the incline. Now we are going to go and play with the main diagram now. All right? Loniel, I don't know how you were taught, but you don't draw the triangle. When you draw the triangle, you are drawing a force diagram. And there's a difference between a free body diagram and a force diagram. So you can use a light pencil to get your way out, but erase that thing when you're done. A free body diagram requires just a dot. Okay. All right. Now, if I go back to my diagram, this is what my diagram looked like. And please, I have multiple questions. I'm just going to look at 1 or 2 per topic. Is that okay? The concept remains what? The same. You should have seen that after doing a lot of question papers. All right. So what do I have? I have that, right? What was our diagram looking like? Our normal was like that, right? What else? Our gravity was like that. Our frictional force was like that. And, all right, now look at what I'm going to do here. I am now playing with the diagram now. This is where the real physics now is. Now, your inclined plane looks like this. Remember, I have submitted the original one I needed. My plane is like this. And if you remember when I defined friction, I said it is always parallel to the surface. So that's my plane now. Let's play around all of this now. I'm going to use a different ink. What is this? Force applied, right? Now, that angle is what? Because there's an angle there, it means we need to resolve. It means we need to do what? Now, you must know how to resolve quickly. There's a short way to resolve. If you don't understand that, then you need to go through your trig ratio. But one thing I know is this. The side that is opposite. We even said it when we're doing maths. Opposite will always go with sine. Done. There's no need to start cracking your head. So if I look at this, let me use a blue arrow to show you what my resolving force would be. It's that way, right? So one should go this way. Now this is where I complete a triangle. All right. This is where I'm going to complete what? A triangle. Is that fine? And then the second one would be that way. And what would this be? Force applied, we can call it X. Is that fine? And this is going to be force applied Y. Now it is perpendicular to the what? To the surface. All right, my diagrams are a bit skewed. Okay. It is now perpendicular to the surface. I'm going to redraw this diagram now and draw all the forces for you. So what would I have now? This is what I'll now have. My free body diagram will now look like this. Now I'm going to draw your FG parallel and your FG perpendicular this time around. So what do I have? My normal force is still that way, right? Is that fine with you? All right, which is perpendicular. Now your Fy is also perpendicular now, right? So that should also go that way. Please try to draw them parallel. Okay. What else? What's that? Friction, right? What else here? Fx. Are we together? Now I am not going to draw Fg anymore. I am going to draw Fg what? Parallel. Which must also be what? Parallel to the surface. Is that fine? And then Fg what? Perpendicular. Now these are all the forces that we have drawn out. This is Fg perpendicular, right? What is this? Fg parallel. Are you with me? What is this? Frictional force. What do you have? Normal force. Now, what is this? Fy, the force applied, but it is now what? Perpendicular to the surface. And what is this? F what? X. If you get this free body diagram, the whole of this question is done. I promise you. I promise you. Now, I told you that the one that is opposite, what do we use? Sine. So, Fy here will be what? F sine of the angle. It means my Fy is F sine of the angle. What will Fx be? Cos of the angle. What is your Fg parallel? Fg parallel, what's the formula? All right, now we are going to have a problem. We're going to have a problem. I know you were taught with theta. Those of you that I thought know that I don't use theta there. Do you notice there are too many thetas here now? You are going to get confused. All right? And what is this? Mg cos alpha, where alpha is the angle of inclination. I use alpha all the time. Even when I get to work energy and power, I maintain my alpha because I don't want you to get confused with the too many things. All right. Please take note of how I drew my free body diagram. Take your time. There's enough time to draw. The more you simplify this, the faster you work. Sometimes you clean and clean and clean because you want to be a hero. Too smart to draw out things like this. If you take your time to draw things like this, exam become very, 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 very what? Easy. All right. What is the examiner saying we should calculate, by the way? Let's go check. Examiner says calculate the angle theta that the straps make with the incline. By the way, we're moving at constant what? Velocity. So we know that acceleration is equal to 0. Please ask yourself, which forces are directly linked with the object in terms of its direction of motion? Which ones are controlling the object? It's the horizontal what? Forces. These are the forces. That's what you ask yourself, guys. And we know that acceleration is equal to what? 0. Do you want to try to calculate that for me? Once you say acceleration is 0, we are using Newton's what? Some of you think that you'll always ask you Newton's second law. Welcome. So what are we using? Although we are going to use Newton's second law, right? Okay, guys, let's do this. Just before we calculate, I hope everybody's okay so far. Please feel free to ask. Is that okay? How is the object moving? Up the plane, right? Make that what? Positive. So this becomes positive, right? What will this become? And so when we say F net is equal to MA, what forces do we refer to? The one in the red box, right? Those are the ones controlling the object. By the way, do we know Fx? What is it? F cos. Are we fine? Which is positive, right? Plus, what about friction? Negative what? Friction. We'll go and get all the values later. Plus what? Negative mg sine what? Alpha. Are you with me? Equals to what? Ma. Write that formula down. You're going to do the maths. The physics is done, by the way. The physics is finished. Everything you need to do now is to do what? Substitute. That's all that you need to do. Are we okay, guys? All right. Can we do the substitution now? Did I just lose this, guys? Hi, Little. Let me just check. I might have just lost you guys. Yes, I figure that. Just a moment. I should have you back. All right. So that's what we have. I hope you guys got the whole formula thing. Let me try to redo the formula for those that I lost online. All right. We said F net is equal to MA. We're using Newton's second law. Although we didn't state it, there are three forces. Number one, we said what? F cos theta, which is our parallel, plus negative what? What was the other one? Negative friction. All right. Plus negative FG parallel, right? Which is mg sine alpha. I hope you understand my alpha, guys. There are too many thetas on the diagram. You might just get lost with which one to use. And that is equal to, okay, before we put in 0, that is equal to MA. All right. So can I then ask that you do the substitution now, although I am done with my own job? It's your math teacher's issue now. All right. Now the question is, do we know the force? Do we know the force? All right, you have that formula, right? So I'm going back to a diagram where we need to get all the data now. And then you quickly calculate. Guys, calculate as fast as possible. All right, there you go. Quickly. Find all the forces that you need. Yes, friction is negative. At here, friction is negative because it's moving in the opposite direction. You do all of that on your free body diagram. That's why I call it a working diagram. The alpha, remember, is the angle of inclination. So that's what I use. So for me, this is my alpha. Please quickly substitute. You should be fast now. We're not talking and making noise. If you are lost, please let me know. If you are lost, please let me know. We should be working out answers just now. All right, you should be giving me answers now, guys. You calculate as if you are calculating forever. Huh? 37,98. Come on, guys. We should be done by now. It's just maths, guys. It's just maths now. Thank you. 37,98. The physics is over, guys. Long ago, physics finished when we drew the free body diagram. This is why if you don't understand the free body diagram, you are going to be in a big mess. How do you get your free body diagrams right? Read first. When you read, pick out the forces. You must know how the forces are acting. You're not getting the answer. What are you doing mathematically? Guys, just substitute. I don't think there's a train smash. Is this a train smash, guys? So what's wrong? What's wrong with the maths? What is F? I think it's 51. Yeah, so what is the issue? 51 cos? What is the friction? Plus minus is minus 1. Plus times minus, negative. What is the mass? 8. What is G? 9,8. Sine what? 30. What is the mass? 8. What is the acceleration? 0. Come on. We've done maths paper 1, we've done maths paper 2. This is grade 8. You don't believe this is grade 8? This is grade 6 even. I mean, if you give this to a grade 6 learner, they must get an answer. And then you know your course. When you want to do that, what do? You use your ARC course, right? And get your answer. All right? Please go and do the math. You said 38, comma? 37, comma? All right. I'm moving on, guys. You have a full day to do that math. Please make sure you get that math. I have a lot of work to do tonight. Determine the magnitude of the what? Normal force. Okay, you're talking a lot now. Determine the magnitude of the normal force. You go back to your diagram. End of story. That's why if your free body diagram is wrong, everything else is wrong. Go back to your free body diagram. We're looking for the normal force. Now, where is your normal force? It's on the vertical now. I'm going to use a blue to represent that. My normal force is here. So this is what I'm working with now, guys. That. How many forces? 3. How many forces are acting upwards? Why 3? How many forces are acting upwards? 2. How many acting downwards? 1. All right? Atia, I cannot be doing this basic sum. I can't. Even with my head, I can try. I'm telling you, 51 cos theta minus 1 sine, that is 4, that is 39,2. And 39,2 minus 1 will give what? 39,2, that will be 40,2. Am I right? 8 times 0 is 0. You need to move that over there. And cos theta will be what? 40,2 over what? 51. And then shift cos. You get 37. 30. You cannot suffer in maths with water and petrol and still suffer here. All right? Now I want to work with my normal. How many forces are pointing up? 2. How many are pointing down? 1. They must be at equilibrium. It means they are equal. And when forces are in the same direction, some of you need to make small notes as I'm talking. All right? When the forces are in the same direction, what do? We add. Some of you need to make those small notes. Whatever note you have tonight will be more important than your January to November 8th note. So you need to make those small notes. When forces are in the same direction, you do what? You add. Look, the questions I selected, I'm basically trying to cover everything, all types of questions, if you check through. So, can I say that N plus Fy should be equal to what? Fg perpendicular, because they are in equilibrium. Google, you're talking too much now. What's the issue? The maths. How can this simple maths be a problem? Okay, now we have two forces pointing up, right? Normal plus Fy should be equal to what? Fg perpendicular. This is why your free body diagram is the main thing. I'm looking for normal, right? Okay, so can we say normal is what? Fg perpendicular minus Fy. Do we know the formula for Fg perpendicular? What is it? Mg cos alpha minus. Do we know the one for Fy? Do you remember what it was? What was it? F sine. Now, I don't know if you, look, check this. I want you to check something here. Do you know you can confuse yourself now? Those angles are not the same. We're not referring to the same angles. All right? So please, if you would walk through, you don't want to come out of the exam and say, yo, I used the wrong angle. No, 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 no. Guys, do you want to get me normal first now quickly? 30. 36,51. I'll give you 30 seconds. 1 minute maximum. We substitute, guys. And you know your angle now. What's your angle? Your angle of theta, what is it? 37. You always take two decimal places. We always take, but you only round up at the end.
You are making life very difficult for yourself. Shift cos, what you have? 40,2 divided by what? 51. Two decimal places, 98. End of story. Not 38. Why do you have time for all of this? No, man. Already you have rounded off here. That's why you're not getting the answer. Google, in the exam, do this and write your final answer. Full stop. Next question.
36,51. Can I move on? Guys, please don't do all of this. X plus X is 2X, then 2X, you move to the other side. It's not maths, man. This is physics. We go straight. But you show your substitution, right? Let me show the substitution here. What is my mass? 8. 9,8 cos what? 30 minus 51 sine. What's the angle? 30. 7, you get your answer. Don't say cos 8, first press 8, 9,8 cos 30. Then you get 22,25 minus 51 minus there's no mark for that. Some of you pity your calculator. That shame. Poor calculator. It's going to do all of these things. Why did you buy it? Put the whole thing at once and get your answer. This is me moving on. We have lots of questions, so you need to catch up fast, guys. For those of you still doing side talks, you will be lost. The pulling force on the suitcase is now applied parallel. I want to teach you how to deal with these questions. Please, you are like, some of you say, but it's just 1 mark. That 1 mark is important, eh? That 1 mark is 0.3%. In fact, it's 0.33. It's bigger than 0.3. The pulling force on the suitcase is now, please listen to this skill, is now applied parallel to the incline. How does this change affect the normal force calculated? If you don't know how to reason things out, you can walk through by calculation. It takes a few seconds, but you'll get your 1 mark. Hello, guys? It takes a few seconds, but you need that 1 mark. Now, what am I going to do? Because some of us, we cannot, those of you talking at the back there, I don't understand. The pulling force is now applied parallel. Go back to the diagram and check something. To say, okay, look, they said, how will this affect what? The normal force. Go back to the diagram and say, okay, look, this person is no longer pulling at an angle. This person is now pulling where? Parallel, right? With the same what? 51. How will this affect the normal? Do you see what I did, right? Don't guess. If you are guessing, you have 30% chance, 0.3, of getting it right. In fact, the probability of getting it wrong is more than the probability of getting it right. Probability of getting it wrong is 0.67. Probability of getting it right is 0.3. Why do you want to get it wrong? This is what I'll do if I were you. I will change this into what? Parallel 51. That's what the examiner said. What is my new free body diagram? My new free body diagram is just that, right? Normal. Does that make sense? This time around, there's no more fx and fy. Do you see that? There's no more what? Fx and fy. Now, what do I have? Fg. Is that fine? Oh, so normal is now equal to what? Oh, awesome. You know you can quickly get that answer. Mg cos alpha, right? What is your M? 8. What is your G? Cos what? But if you know maths, you should be able to answer this question already. Do you know for normal force we're subtracting? This one is going to be bigger. But I am talking. Look, I am talking to when I teach. Those of you know that when I'm teaching, I try to explain to the weakest learner. Is that okay? So if you are struggling with interpretation, don't say I think. I know. That's what we're working at. And how do you do that? You saw what I did. I changed the 51 at an angle to the 51 parallel. And I quickly did my free body diagram, right? It's just normal up, FG parallel. Compare that answer to the one you got earlier on. What's the correct answer? It will what? Increase. Wait, are you not sure of that 1 mark now? What's your final answer? Luckily, they are not even telling you to explain. Amen. Should they tell you to explain, what will your answer be? I'll now guide you through. Did that make sense, guys? Now, how do you explain? This is the explanation. All right? With F being parallel, with F now parallel, let's say with F, force applied, now parallel, there is no vertical component. Of the applied force. Of the applied force. Which makes normal force to be equal to what? Fg perpendicular. Don't write too many things that you don't even understand, even you yourself. Some of you write so many things so that they know that you are doing science. and the FG will now be opposite on the other side of the international forces, and the interaction between them will now be equal because of Newton's third law. And when Newton's third law is finished, we bring in Coulomb's law so that we can now understand the relationship between... for what? You want to become a professor. And then when you multiply it by the mass then becomes directly proportional according to Newton's second law, which, come on. Israel, what we did was, the examiner said, please, guys, look, physics is quite easy to work around. Is that okay? It says the pulling force on the suitcase is now what? Applied parallel. Go back to your diagram and make it what? Parallel. Calculate the new normal force. Guys, as long as you can get your free body diagram right, all calculations are easy. Israel, is that okay? So what we did was we made our force to be what? Parallel. Is that fine? Once we got the parallel force, we recalculated our normal force. For some of us that cannot deal with applications, at least you should be able to deal with calculations. All right. And that's it. It will increase. I hope it makes sense. We have... You would notice that question is different from this one. So I brought in something different. Yes, there's a question? Okay, hold on. Let me cut this. We have another question here. There are different types, guys.